So originally, I had the test planned for Wednesday. I think we're going to move that to Thursday. Um, pardon me. Test is going to be on Thursday. So we're going to have a quiz tomorrow on this stuff. And then we'll also, on Wednesday, do some review together. We'll go through the quiz and do some review together. And maybe we'll start that on tomorrow after the quiz, so that we'll have our test on Thursday. Okay? So, quiz tomorrow, test Thursday on slope. So, we're going to talk about one of the applications of slope, which is rate of change. 1 year ago, Becky started working at a grocery store. She put $100 per month into her bank account. She already had $200 in the account. The table shows the growth in Becky's bank account. So you can see at time zero, she had $200, and that's what it says. She started with $200 in her account. And then every month, she deposited an extra 100 in there for savings. So after the first month, she started with the 200, she put 100 in, now she has 300. In the second month, she put another 100 in, now she has 400, and so on. That pattern continues all the way through. So it says on grid paper, plot the data in the table. So we're going to draw a graph of this data. And when you're drawing a graph, the data that's in the first column or the first row always goes along the x-axis. So the time in months is the first column. The second column is the amount. That will go along the y-axis along the side. But the first set of data in the table goes along the x or the horizontal axis, which in this case is time in months. Now, when you draw your graphs, you have to make sure, that you label your axes. So we talked about this in our graphing chapter. We have to label our axes. So time in months goes along the side, or the bottom, and then our amount in dollars goes on the side. If we look at the table, we have to go all the way up to 12 months. So the other thing we have to do is make sure we choose a suitable scale. So if we start zero here, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 vertical lines. So we can have each line being one more month. So the first line will be 1, and then I'll write a 2 for the second month. The next line will be a 3, then I'll write a 4. And I only do this just so that the numbers aren't too squished together. You could certainly put a number for every line, but this just kind of spreads the data out. And then along the side for the amount, we have to start at a minimum of 200 and go up to 1400. So if we start at zero and each horizontal line counted for another $100, we'd have to have 14 lines to fit all this data in. So let's see if that'll work. 1, 2, 3, 4, 5, 6, 7. I think it's going to work. 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 horizontal lines. So we can let each line be an extra $100. So the first line is 100, the next one is 200. So again, I'm only going to write every second one in there just so the data isn't too squished together. And now we'll put our points here. So the first point is the point 0, 200. That's what they start with. That's what she starts with in her account. And then in the first month, she puts another 100, so now she's up to 300. And then 400, then 500, then 600, and so on. So if we put all the points there, we ended up the last point being the point 12, comma 1400. And you should not draw a line through the points. Because if you draw a line, you're saying that the data is continuous, meaning it's continually changing or increasing, but it's not. A deposit is only made once a month. So if you draw a line, that would show that her money is growing continuously, daily if you want, and that's not what's happening. You should only draw a line if the data is changing at a continuous rate, and it's not. So we should not draw a line through the points, but it still shows a linear pattern. Okay? Part B says determine the slope of the line that would connect the points. So if you were to connect the points, what would its slope be? Well, there's a couple different ways that we could do this. One of them is by using that slope formula. So remember that for the slope formula, you have to have 2 points. And we can choose any 2 points from this table. So for example, I could say that point 1 is the point 0, comma 200, and then I could skip points if I wanted to, or I could say the next point is point 2. It doesn't matter. But I'm just going to skip some points and say that point 2 is 5, comma 700. You see, if we look at this data, it's increasing at a constant rate. If you were to draw a line through the points, they would all line up as part of one continuous line. We've said that you cannot draw a line because that means that the amount is always increasing, and it's not. It's only increasing once a month, but it's still going up at a constant rate. So because of that, it wouldn't matter which 2 points we chose to find our slope, our answer would be the same. So I said that point 1 was the point 0, comma 200, and point 2 is the point 5, comma 700. And the reason I'm writing this down is because remember what the slope formula is? It uses x1, y1, and x2, comma y2. The slope formula says that m, the slope, is y2 minus y1 over x2 minus x1. That's the slope formula. And we've learned that we can use this to find the slope of a line if we have 2 points on it. So this is one way we can find the slope. So if I use that formula, y2 is the y value at point 2, which is 700, minus y1, which is the y value at point 1 of 200, over x2 minus x1, 5 minus 0. So 700 minus 200 is 500, over 5 minus 0 is 5, and when you divide those, you'll get 100. So we found that the slope is 100. And another way you could have got that is by using the rise and the run. So for example, if we go from the first point up to the second point, we'd go up 1 unit and to the right 1 unit. Now remember that slope is rise over run. So you're rising $100 and running 1 month. So using rise over run from the graph, you're rising $100, you're running 1 month, 100 over 1 is still 100, which is what we got using the formula above there. But also, it's not just a number, it has meaning. And remember, slope is rise over run. The rise is going up and down, and the up and down axis is the amount in dollars. The run is going left to right, and that's the horizontal axis, which is the time in months. So you see, if we interpret what slope means, because it's rise over run, the rise is the money divided by the run, which is the months, In this case here, it would be $100 per month. That's the definition of the slope. And it wouldn't matter whether you're going from month 1 to month 4 or from month 5 to month 12, the slope will be the same. The rate of change never changes. And we know that again because all those points are linear, they line up. If we wanted to draw a line through there, they would all line up. We shouldn't draw a line, and I've explained why, but it doesn't matter which section of the graph you look at, the slope will not change. It's always $100 per month. Part D says, what do you notice about the rate of change for each time period? It's always the same. And just to again explain that, if you go from month 1 to month 4, so using a different set of lines here, I'll use a different color, from month 1 I should say, up to month 4, and let's actually write this in here. So this will be month 1 to month 4. You can see that you're rising 1, 2, 300 up, and you're running 1, 2, 3 months to the right. You see 300 over 3 is still 100, or $100 per month. And if you went from month 5 to month 12, so again, if I use a different set of lines here, month 5, which is here, up to month 12, so here you're going to rise 1, 2, 3, 4, 5, 6, $700 up, and you're going to run 1, 2, 3, 4, 5, 6, 7 months. From month 5 to 12, it's 700 divided by 7, rise over run, rise divided by run, you're still getting 100 per month. The rate of change is the same no matter which section of the graph you use. So that's why we say in part D, it's always the same, which we can say is 100 per month. If you have a linear pattern or a line, it means that the slope never changes. The rate of change never changes, no matter what section you use. So on this next page, it says Adam picks blueberries to be sold in a local market. The table shows Adam's earnings for 1 to 5 boxes of blueberries. We're asked to plot the data in the grid below and see what the points form. So remember, the first thing in the table, which in this case is the number of boxes, goes along the bottom. You always have to label your axes. And along the side will be the earnings in dollars. So that's the first part. We have to label our axes, just like we did back in our graphing chapter. And we have to choose a suitable scale. The number of boxes has to go up to at least 5. So if I start with 0, maybe I'll skip a line and put 1, skip a line and put 2. And all that does is just make sure the data is not all squished together. The earnings have to go up to $15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They will all fit here. So this is 1, 2, I'm going to put 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, $15. My first point is the point 1, comma 3. Then we have 2, comma 6, 3, comma 9, 4, comma 12, and 5, comma 15. We could also put 0, comma 0 on here, even though it's not part of our table. If he doesn't pick any boxes, he's not going to earn any money. So once again, we've got a linear pattern here. This question asks, what do the points form? Well, they form a linear pattern or a linear trend. We should not draw a line through the points, though, because that means he'd only get paid for part of a box. And we don't know that that's true. It's possible, but I guess they could weigh them to figure out how much of a box he has. But we're not given any indication that he gets paid for part of a box, so therefore we will not draw a line through the points. Part B says, how does the number of boxes sold affect his earnings? Well, the more boxes he sells, the more he gets paid. Okay? You can say as the number of boxes increase, his earnings will increase. They go up. Determine the slope of the line that will connect the points on the graph. So again, we can do this using the formula or using the graph and doing the rise over the run. So if we go from month 1, let's say up to month 4, we can use any combination of points here. You could go from month 0 to 1, 1 to 2, 3 to 5, or in this case, I went from month 1 to month 4. But you can see you're going to rise 1, 2, 3, 4, 5, 6, 7, 8, $9. So the rise here will be $9. And the run will be 1, 2, 3 months. That'll be the run along here. So from 1 to 2, that's 1 month. And then 3 is the second month. Then 4 is your third month. So the slope of the line would be 9 divided by 3, which would be 3. And in this case here, you're dividing dollars per month. So it'll be $3 per month. That's the rate of change, and that's what it means. The slope tells you the rate of change. And to determine what it means, to interpret it, look at what your axes are labeled with. The earnings is along the y-axis. The months or boxes, and did I write that down? No, it's $3 per box. Sorry, not month. The boxes are along the x-axis. So when you go rise over run, it's dollars over boxes or dollars per box. All right, looking at example 2. What is the change in the x values from one row to the next? So we're just given a table with x and y. X is increasing by 1. So it is plus 1 on the x in the x table. In the y values, they're going up by 2. And you can just see what the pattern is. They're going up by 2. So the rise is 2 for every run of 1. Y is going up by 2s as x goes up by 1s. Remember, the rise is up and down, so that's your y values. The x's is the run. That's going left to right, your x values. So to find the rate of change, it's the change in y, which is the rise over the run, the change in x. The change in y is 2 over the change in x, which is 1. The slope of that line is positive 2. And we can say that that is the rate of change because the rate of change is a constant. If we look at each case, y goes up by 2. So because of that, if we wanted to do it using two different points, let's say we went from the first point to the last point, so y is going from 4 all the way to 12, that's a jump of 8, and x is going from 0 up to 4, so that's a jump of 4. If you use those two values to calculate the rate of change or the slope by going rise over run, it's rising 8 for a run of 4, you still get an answer of 2 for the slope. As long as the rate of change remains the same, it doesn't matter which starting point and which ending point you use, the rate of change, the slope should be the same. So in this case here, we've got a graph that shows the mass of food in kilograms that a mass of salmon would eat in kilograms. And the rate of change is constant because you've got a straight line here. And the reason a straight line is used here, because it's possible to have kilograms of food in part of a kilogram, 1.5 kilograms, 1.2 kilograms, 2.128 kilograms. And it's also possible for the mass of a salmon to be part of a kilogram. So, determine the rate of change in the mass of the salmon. And then we want to discuss the relationship between the mass of a salmon and the mass of the food that it contains. So the rate of change for the mass of the salmon, you can see that it's always going upwards. And same thing with the mass of the food. So the mass of the salmon, you can see we've got points on here, goes from 0 up to 2.5 kilograms up to 5 kilograms. So if we just use the 3 points here, starting at 0, 0, the next point, the mass of the salmon is 2.5. The next point, the mass of the salmon is 5. So the rate of change in the mass of the salmon is it's increasing by 2.5 kilograms. Describe the relationship between the mass of a salmon and the mass of the food that it consumes. Well, if we go from 0, the point 0, 0 to the point 3, 2.5, so again, if we calculate or see what our rise and our run is, so our relationship is rise over run, and for the section that I've shown here, it's rising 2.5 kilograms. That's the mass of the salmon, and it's running 3 kilograms. And if we divide those two numbers and see what we get, 2.5 divided by 3, it's a decimal, 0.83 repeating. So if we interpret what it means, it's kilogram of fish per kilogram of food. The slope is increasing. It's rising as you go left to right. 0.833 repeating kilogram of fish per kilogram of food. That's what this means. For every kilogram of fish, they're going to use 0.83 repeating kilograms of food. That's what it means. All right, part C says, suppose fish farmers gather data on this relationship regularly. Which of the following would a fish farmer prefer to see and justify your answer? Should there be a steeper slope, or a less slope? Well, if you look and let's say you had a line that had a steeper slope. So let's just draw one in there, a different one that has a steeper slope. So that would mean that if we use this point right here, that would mean that a fish that is 5 kilograms only uses 2 kilograms of food. Whereas the line that we have here would show that a fish of 2.5 kilograms would use way more food, 3 kilograms. So the fish farmer would probably want a steeper slope because it would mean that his fish are eating less food. So he would want a graph with steeper slope because it means the fish are eating less food. Now there's a couple of factors that the farmer would want to look at. What is the cost of food? And then also, what does the effect on the weight of the fish, what does the effect of eating less food have on how big his fish get? Because he's probably going to get paid per kilogram of his fish. So he has to kind of balance that. What is the cost of the food? And then if his fish eat less food, how much less weight are they putting on? Because that will affect what he gets paid. So this next one says that Nicole records her heart rate during an aerobic class. Her results are shown in the graph. When is Nicole's heart rate increasing? How do you know? When is the rate of change? What is the rate of change for this interval? And so on. So this is not one continuous line. You can see that this graph has 3 different lines. The first part of it, where the line is increasing from 0 to 10 minutes. The second part where the line is staying the same, meaning that the heart rate isn't changing. And the last interval where the line is decreasing or the heart rate is going down. So we have 3 different intervals to look at. Part A says, when is her heart rate increasing? Well, from 0 to this point here, which corresponds to 15 minutes, that's where the heart rate is increasing. So when is it increasing? From 0 minutes to 15 minutes. And we know that because the line is rising. The line is rising, so that's how we know that that is where her heart rate is increasing. What is the rate of change in heart rate for this interval? Well, if we calculate the rise and the run, let me change colors here. If we say it starts at 65, if we say it starts at 65, it's going up 5, actually it's going up 10 to 75, 20 to 85, 30 to 95, 40 to 105. So it's rising by 40 beats in 15 minutes. So it rises 40 beats over 15 minutes. Remember, and the slope is rise over run, which in this case is 40 beats divided by 15 minutes 40 divided by 15 is a decimal, a repeating decimal, 2.6 repeating. So we'll say approximately 2.6 with a line over the 6 because it repeats. And slope is rise over run. The rise are the beats, the run are the minutes. It'll be beats per minute. Beats over minutes or beats per minute. So that's the rate of change for that part of her exercising. So obviously she's exercising strenuously because her heart rate is rising. For 20 minutes during the class, the heart rate did not change. What was her heart rate at this interval? Well, again, we're just asking for the heart rate here, which is 105 beats per minute. Beats per minute. And how do you know it did not change? Well, because the line is flat. It's not rising or lowering. The line is flat. In other words, not rising or lowering. That's how we know. Okay, so we'll stop there. I'll hand out the assignment. Remember, tomorrow you guys have a quiz on slope, and our test is going to be moved to Thursday instead of Wednesday. So we'll be doing some review in class together to help you get ready for the test. But you have a quiz tomorrow.